Okay, welcome to lesson 3 of organic chemistry and title for today's work. Let me just make sure I've got my pen turned on. Yes. Title for today's work, how do we make petrol? So, when you've got that written down, you can obviously pause whenever you want with these. Can I just say, if you're doing it as a recorded lesson, can you please upload the photo of your work to Google Classroom or email it to me? Thank you. What did we do last lesson? Now, if you weren't able to do the lessons on crude oil and how is oil formed, these questions are going to be difficult. What I'd suggest you do is write these questions out, leave 2 lines to answer that one, leave 3 lines to answer that one, 1 line, 1 line, 1 line. Now most of you will have done that work, so you should be able to answer those questions, and then you can go through and mark it in a minute. So unpause, pause now, and then unpause when you're ready to move on. Okay, so what is crude oil? Crude oil is a mixture, that's the important bit, that's why it's not very useful. It's a mixture of chemicals called hydrocarbons. Okay, next one down. What is crude oil formed from? Crude oil is formed from the remains of living organisms that didn't decompose over millions of years. And that's the important thing. It does take millions and millions of years for these remains of living things to turn into crude oil. Why is it a finite resource? Because it will run out. We can't remake it, can't recycle it. What is a hydrocarbon? It's a chain of carbons and hydrogens there's no other elements there, it is just carbon and hydrogen. And what's the general formula? It's a formula for a family of organic compounds. The example that you should know already is that for the alkanes, the number of hydrogens is 2n, so you double the number of carbons and then you add 2. And those of you who were in the live lesson, I know 3 or 4 of you got that before I even told you that. So well done. Okay, there's the answers. And here is an oil refinery. And an oil refinery is somewhere where we take the crude oil to turn it into useful chemicals. What we say is we separate it into its different fractions. So in crude oil we can take out a fraction called petrol, and we can separate out a fraction called diesel and bitumen, and they're the ones I've mentioned so far in previous lessons. So these and other fractions can be separated out so we get the useful compounds. Now there's one of these over near Southampton, you can see it from Gosport, Fawley Oil Refinery. The crude oil comes in from all over the world, mostly from Saudi Arabia, etc. The crude oil comes into Fawley, and in this oil refinery at Fawley, what will come out of there is loads of tankers carrying petrol all around the south coast, diesel all around the south coast, and bitumen to all the different manufacturers that need it. So how can we separate them? from each other. And what we were looking at before was we have the shortest chain, methane, and then a longer chain here, butane, and they get longer and longer. And all these different chains have different properties. And the property we're looking for here is their boiling point. The way we separate liquids from each other is liquids with different boiling points can be evaporated at different temperatures. And we call that process distillation. Right, worth making a note of this bit and the fact that the difference we're looking for in the different fractions is they have different boiling points, and we can use a process called distillation to separate them. So how do we do it? Well, what we started with originally, let's just say we've got a barrel of crude oil. In our barrel of crude oil, sorry for the drawing quality, we've got these little chains of hydrocarbons, and we've got, so they might be petrol, and we've got these ones that might be kerosene used for aircraft fuel, and here's diesel chains, and then you've got the really long chains. That is a really thick viscous liquid called bitumen. Now, if we started to heat this up, short chains have a lower boiling point. Now what that means is, if I started to heat this up, the short chains would turn into a gas first and leave behind the longer chains. If I then heated it up a bit more, then the next lot of chains would start to evaporate because it's at a higher temperature. So the important bits on this diagram, if you could probably draw it in a pencil neater than me, is that long chains have a high boiling point. Okay, so when you've got that down, then carry on. Until then, pause. Going through, and it happens inside a machine like this. Now, in size-wise, this is taller than the school. It's about as wide as a classroom, and it's called a fractionating column. We're going to do a diagram of it in a minute, so you don't have to worry about the picture there. But the apparatus we use is called a fractionating column, and it separates the different chemicals in crude oil. And obviously you're asking how. Now, I'll try and paste this link into the Google Classroom as well for you to watch. It's 4 minutes long and it sums it up brilliantly. That will really help you to understand what we're going to do next. So could you pause, and if you can't find that link, just type this into YouTube exactly as it's written there in the URL. Watch that 4-minute video. That will really help you visualizing what I'm trying to explain. Okay, just find the right bit. This is a diagram of that fractionating column. So you've seen a photo of what it looks like, and now you've just watched that YouTube video, the explanation. So here at the bottom, I need to change colour pen, I suppose. Here at the bottom, they heat the crude oil so that all of it turns into a gas. That's called, they have vaporized all of the chains. And they start to go up. At the top here, it's cool, and at the bottom here, it's hot. So as you go up this column, the temperature lowers. So let's say, for example, you are a small hydrocarbon chain. Not, well, you can do, you are. So if you imagine it, you've just been heated and turned into a gas, and you go up here, there you are, and at this temperature you're still a gas, and at this temperature you're still a gas. because you boil at a low temperature, and at this temperature you're still a gas, and you get up as far as here, and at this temperature you're still a gas, and you get up to here, and now it's below your boiling point. So what happens to you, this small chain, is you condense. You turn back from being a gas into being a liquid, and you fall to the bottom here, and you dribble out here, and you're taken away and processed further to be ready because you're a piece of petrol. Now let's say, second example, let's say for example you are a slightly longer chain like this one. Here we are, I'm down here, I'm a gas still. I carry on going up the column. Uh-oh, it's gone below my boiling point. I condense. I come out this pipe, and there you go, I'm a piece of diesel. So this way we end up with all the little chains up here, and then the slightly bigger chains, and then the slightly bigger chains, and then the slightly bigger hydrocarbon chains, and then the slightly bigger ones, and then the massive ones. Now, this diagram looks difficult to draw, but it's not. What I want you to get from this page in your notes before you move on is I want you to just get, if I can find my pen again, there it is. What I want you to get from this page is get down the names of the different fractions that we want, and the properties of the small chains, the properties of the big chains, and the idea that here's gas, small, slightly bigger for naphtha, slightly bigger for kerosene, and then when you've done that, move on. Okay, please do what it says. Draw that diagram. Write on it which bit's the hottest and coolest, and then put these temperatures on there in order. And when you've written those temperatures on your diagram, if you're drawing it in pencil, try and keep it as neat as possible. Please can you then unpause. So pause now and do that. Okay, so you should have the diagram drawn out, you should have the temperatures written on, and what should you have written on here? Well, you should have written that up the top here the temperature is 20 degrees, and the next one down would be 150, and the next one 200, and the next one 300. It says to match each temperature to each number, so there's your 300. And down the bottom here, let's go with 400, and in here 370. So as you can see, it goes from 20 to 150 to 200, and you've labelled on here that at the top is the coolest and the bottom is the hottest. Okay, so when you've checked that you're correct on that, make sure it's correct. Now what I'd like you to do on the same diagram is just add your fractions on. So for example, you'll look at gas, oh that's the shortest chain, it's under 20. Gas, I'll be matching up with number 6. So pause first and we'll go through that. Okay, so hopefully you've labelled them yourself now. So there's the under 20. Then the next one down, petrol, I'll be matching that up with number 5. Then number 4, the next one down, I'll be matching up with kerosene. Then number 3, the next one down, I'll be matching up with diesel. Then number 2, I'll be matching up with fuel oil. And bitumen, I'll be matching up with number 1 at the bottom, the longest chains. Okay, brilliant. Here's our thick black bitumen. Here's our heavy fuel oil, our diesel. Here is our naphtha or kerosene, and here's our petrol. So it's not just the size of the chains and the boiling points that change, also the thickness and the colour. So this sort of sums up what we've done. Hopefully you've got the bits right as we've gone along or made the corrections you need to. As you get longer chains, so here's your small short chain, there's your long ones. As you get longer chains, the colour gets darker, the boiling point increases, and that viscosity, that thickness of the liquid, how easy it is to flow, it gets more and more viscous. Okay, could you please just make sure this word, and this word are in your glossaries and probably written in your own words and clear in your notes from today. And then these are the question starters, and then you've got the other questions down below where it restarts at question number 1 and then goes 2, 3, 4, 5. So when you send me through your work, can you make sure those are answered, please? Then I'll come back to you and let you know if you've got them right or not and give you some feedback. Okay, thank you very much.